What is actually a double sideband? We have been talking about double sideband quite a lot now. So discussing about double sideband, I have already told you like what is a message signal, how it is represented, and what is a carrier signal. To get to know the expression for a double side signal band, if we expand our basic expression of modulation, then it will comes out to be AC plus AM cos omega MT cos omega CT, where AC is equals to 1 plus, if we take AC outside, 1 plus AM by AC cos omega MT omega CT, where XT is AC 1 plus mu cos omega MT cos omega CT. If you calculate it, you will get this result only. On Fourier transformation, you will get 0.5 AC delta function of del f plus fc plus del f minus fc plus 0.5 mu of AC x fm plus fc plus x fm minus. Now this is the Fourier transformation of the double sideband. You can see at fc frequency there is a arrowhead, and at fc plus fm and fm minus fc there is again two sidebands. Okay, to calculate the power of PC, we'll integrate our signal xct, carrier signal, over dt, and from 0 to 2 pi AC square cos square omega dt we'll get AC square by 2. Here I'll suggest you to do the integration, though I have told you all the steps, but still I think in practice of integration will help you to be better at GATE, because you need to solve questions within a time frame of 2 to 3 minutes. Such practicing will increase your speed. Okay, so keep on practicing about integration differentiations so that you'll be able to have a speedy calculation for GATE examination preparation. So power of sideband is mu square PC by 2. Okay, and if you further divide the sideband power into an lower sideband and upper sideband, it will be mu square PC by 4. So total power, as I have already shown you in the example, can be derived by the steps taken above, and the efficiency is total sideband power upon total power. And again that formula which I have told you earlier is derived by this basic formula. The bandwidth of the modulated signal will be 2 FM. Though it has been modulated to a high carrier frequency, still the bandwidth will remain the same. This is a representation of a double sideband. Now again going with a second question on this is a GATE 2016 examination. Throughout my lecture series, you will see a considerable questions which I have taken from exactly from the GATE question that will help you to prepare better, because keep on trying to solve more and more questions that will enhance your practice and help you in solving 65 questions of 1 marks or 2 marks. Okay, in 3 years or 3 sorry not 3 years, in 3 hours of time span. So moving forward, if we see that ST is an AM signal, just like a modulated signal, having 3 frequencies content at 1800, 1600 and 2000. Its actual frequency, if we divide this frequency in 2 pi f, then f will be equals to 1000 in this case, 900 in this case, and 800 in this case. So the 901 lies in the middle. You can go by a thumb rule that what lies in middle of the total spectrum is our signal at FC frequency. If you see that 900 is the FC frequency, then this is a sideband, this is another sideband. And from here we can observe that AC is 20 watt and AC mu by 2, the amplitude of the sideband, is equals to 5 watt. Now substituting the value of AC, we'll get mu equals to 0.5. Now this is a very simple 2016 1 mark question. Now again moving forward, the modulation of DSB. Now there are different techniques which are helpful in modulating AM signals. First, talking about the double sideband, a multiplier modulator is used, having an input mu of xt and output AC cos omega ct plus mu of xt into AC cos omega ct. If you take AC cos omega ct common, you will get 1 plus mu xt. That is our output. By a non-linear modulator, what happens in this, if you see, with the help of the adders and a non-linear modulator, we'll get our message signal. In non-linear modulation, we do b into x square t, squaring a signal, and when you square a signal and pass through a low pass filter, you will get 2am 2a mt plus 4b mt cos omega ct. Okay, that will become twice of the initial message signal, and it will be 4 times of the initial message signal with a multiplication of cos omega ct. Now there is switching modulator and a ring modulator. Not much have been asked. You can just go through the diagram and see how it functions and the basic calculations. Okay, now the balance modulator. Balance modulator is a simple modulator where you can see it consists of 2 modulator and an adder. In first modulator, you are getting an S1T AC 1 plus K KMT cos omega 2 pi FCT. Now this particular signal is for a suppressed carrier, DSB suppressed carrier. If you can see, the power required to carry a carrier signal is not present in the whole expression. It has been dropped. So such kind of signals are termed as double sideband suppressed carrier. These signals are good in amplitude modulation because they require less power in consideration to the earlier signal. And they can be modulated using an amplitude modulator with empty signal minus empty and empty passed through a modulator with an oscillator with FC frequency and added. When these two are added with a minus sign, okay, we get a final suppressed carrier DSB signal. Moving with demodulation of DSB, we have rectifier detector. Rectifier detector is a diode detector with a low pass filter and a CR circuit. You can see with the help of the diode, the waveform is chipped off. When it is chipped off and only a positive frequencies is present, then the variation in the signal amplitude contains the information. These variation in these signals when passed through a low pass filter retrieve us the baseband signal of low frequency and on passing it through C and R, it further deteriorates its amplitude and get you the actual message signal that was originally your message. Now, envelope detector is a follows the output of a modulated signal. Now, you can see a very good example in this, like if you see the amp with the help of the C and R filter, okay, with the help of the C and R, like capacitor and resistor, the output follows the trail of the input signal. You can see with the C and R, it gets charged up to its peak value and then the capacitor discharges till it reaches its next peak value. And it again charges to that peak value and it again get discharged. And it again, when it reaches the signal again, it reaches to its peak value and again get discharged. The whole step is being followed, keeping in mind that RC should not be too large so that it doesn't follow the path of the modulated signal. Now the